Hi everybody, Mrs. Pesic here.
And Miss Bella here.
And we are looking now at section 5.3, which is adding and subtracting rational expressions. And the learning objectives for this section, you'll learn to add and subtract rational expressions and to simplify complex fractions.
Okay, we want to remember that we used to do this with our simple fractions here. So how do we add or subtract fractions when they had like denominators? So we're going to start off with 2 13ths plus 5 13ths. Again, notice if the bottoms are the same, the denominators are the same, all you're going to do is add the top values here. So 2 plus 5 is 7, and then I keep that over 13, so 7 13ths. If we are subtracting, again, as long as the bottoms are the same value, I take the top 5 minus 1, gives me 4, and that becomes 4 thirds.
All right. And it looks like you made hearts on the board, Miss Bella. You must love adding and subtracting fractions. Okay, so now if we do the same thing with rational expressions, if they have a common denominator, then we just keep that same denominator and we're going to just add the two numerators together. So we're going to add x minus 3 plus x minus 2. And we can combine like terms and we'll get 2x minus 5 over x plus 4.
Wait, should I simplify that, or that's my final answer, right?
That's it. I don't think it can be simplified anymore. Can we divide out those x's, Miss Bella?
I cannot divide out those x's in this case.
No, they are locked into terms.
All right, let's try another example with this one. Again, I'm going to notice when I'm looking at this problem that my denominators are the same. So x squared plus 1, x squared plus 1. So my final denominator will still be x squared plus 1. I'm going to subtract the values on top. So I want to make sure I use parentheses here. So the quantity 3x minus, whoopsie, 3x minus 4. There we go. And we're going to subtract 6x plus 1. Now remember, when we have that subtraction outside of our parentheses, I'm going to need to distribute that in. So to help me out, I might do a little rewrite here and say this was 3x minus 4. And then I'm going to have a minus 6x minus 1. So if I wanted to combine like terms in the numerator, this would become 3x minus 6x is negative 3x. And negative 4 minus 1 more is going to be minus 5, all over my same denominator of x squared plus 1. So there would be my final answer in that one.
All right, so if we're going to add and subtract rational expressions with unlike denominators, you're going to first want to find the least common denominator. We'll abbreviate that LCD. So the least common denominator is the least common multiple of the polynomials in the denominator. So to find the least common monomial of a set of polynomials, you're going to factor each polynomial completely, writing any repeated factors as powers. So for example, if we're going to try and find the least common multiple, we might have to factor out an x here. So we'll have x times x squared plus 6x plus 9. And then the x squared plus 6x plus 9 can be factored into x times x plus 3 times x plus 3. And again, we could have gotten that by doing FOIL. You know, product is 1 times 9, sum is 6, and we could work it out and we would end up getting this.
Okay, so step 2, once I factor that, I want to write finishing up here, I want to rewrite this as repeated powers here. So really remember, this would be the same as had one copy of x and x plus 3 I had to the second power. There were 2 copies of that. Okay, so for step 2, I want to list the different factors. If the polynomials have common factors, use the highest power of each common factor. Okay, so let's maybe look at an example here on how to do that. So we have 4x squared y cubed and 6x to the 4th y to the 5th. So if I want to look at the different factors in this one, I notice that in this one I have an x squared, I have a y cubed. So this is really going to be 4, which is 2 times 2, or 2 squared, times x squared times y to the 3rd. And when I factor 6, that is the same as 2 times 3. So I have 2 times 3 times x to the 4th, y to the 5th. So my least common multiple would have to use each of those. If it's repeated, I want the highest power. So my least common multiple for these, I'm going to start off with 2. I have 2 to the 2nd and 2 to the 1st. So I have to use the highest power of that. So this will be 2 to the 2nd. Next, I have a 3 in this one. That's the only one I see, so times 3. For x, I had x to the second and x to the fourth. Using the highest power there, this will be x to the fourth. And I'll finish off with y. Again, we had y to the third and y to the fifth. The highest of those is y to the fifth. So 2 squared is 4 times 3 is 12. So 12 x to the fourth, y to the fifth would be my least common multiple.
Okay, and looking at this next example, we have, oh, don't want to scare you with that. Looking at this example, we have x squared minus 2x minus 3 and x squared minus 6. So we need to find the least common multiple for each pair. Let's factor this one first. Again, you could factor using product sum, or if you can reason it out, I need to have x's here and here, 3 and a 1 here with a negative there and a plus 1 there. Does that look right, Miss Bella?
Yes, it does.
And then this one factors into x here and an x here. I need a 3 here and a 2 here, and I need a minus there and a plus here. So if I want to find the least common multiple, I see an x plus 1 here, but I don't see any x plus 1 over here, so I know I must have an x plus 1 to the first. I see an x plus 3 here and here, and that both just to the first, so I need an x minus 3 to the first here. And lastly, I see an x plus 2 here. I don't see any over there. I have to have that represented, so I get an x plus 2. So this is going to be the least common multiple for this problem.
All right, so we have our first must do, and you're going to find the least common multiple of x squared minus 4 and x squared plus 5x plus 6. Again, suggestion, you might want to factor both of those first and list any factors that are repeated, and then look for your least common multiple by including each factor to the highest power. All right, now when we wanted to add or subtract rational expressions with unlike denominators, again, we're going to have to get both sides to have the least common denominator, just like fractions that were made up of integers. So if I wanted to recall how I would add 2/6 plus 3/10, well, my first thing I'm going to do here is I'm going to get my least common multiple or least common denominator, which in this case would be 60, or we're going to write this as 2 times 3 for right now. Okay, 2 times 3. And the next one would be 3 over 2 times 5. So my least common multiple is going to have to, or denominator, whatever we want to call it in this one, I guess, because we have a fraction, is going to have to include each of those factors at least to the highest power. So I'll need a 2, I'll need a 3, and I'll need a 5 in that. So my least common multiple is going to be 30. Okay, so I'm going to multiply by what's missing in each of them. So I'm going to multiply, I was missing a factor of 5, so I'll multiply that by a form of 1, which is 5 over 5. And then I'll multiply my next one, 3/10, by what it was missing. It was missing a 3, so I'll multiply it by 3 over 3. So I will multiply the tops together to get 10 over 30, plus, again, multiplying the tops and bottoms, 9 over 30. Now that my bottoms match, I can add across the top and have a 30 on the bottom for my denominator, so it'll be 19 over 30.
Okay, and now we're going to do the same type of thing except with rational expressions that we're adding. So if we want to add these two fractions together, we're going to add and also identify any x values for which the expression is undefined. So let's start off by finding the least common denominator. Let's factor that first denominator. That factors into x plus 4 and x minus 1, and then the second fraction just has x plus 4. So the least common denominator is going to have x plus 4 to the first, because that's represented once, and then we need an x minus 1. All right, and that is going to be our least common denominator. We already have that as the least common denominator for the first fraction, but we need to get that in the second fraction. So let's multiply the second fraction by x minus 1 over x minus 1, so we can get that least common denominator in both fractions. So we are going to have x minus 3 over x plus 4 times x minus 1, and then we can distribute that 2x to the x and the minus 1, and we'll have 2x squared and a minus 2x over x plus 4 times x minus 1. Now we can, since we have the common denominator, we can add the two numerators and put them over that common denominator. So we will have x minus 3 plus 2x squared minus 2x, and it's all over the least common denominator, x plus 4 times x minus 1. And now if we can clean up that numerator a little bit, we'll have 2x squared, and we'll have a minus 1x, and a minus 3. And that's all over our least common denominator. And that's it. We're done. But we do need to identify any x values for which the expression is undefined.
So if I want to know where it's undefined, that means what number could I plug in for x and it would, give me something that could not work out. So in a fraction, our only issue is going to be any number that would make you divide by 0. So in this case, any numbers that would make me divide by 0 are numbers that would make the bottom or the denominator equal 0. So I'm going to set each of those equal to 0 and solve for my values of x. So I'll say my first one, if I subtract 4, it would be undefined if x is negative 4. That looks a little weird there. Negative 4. Also, if I say x minus 1 equals 0 and add 1 to each side, x would equal 1. So I'll have two values in this case that could make this undefined.
So we really want to say x cannot equal negative 4 and x cannot equal 1.
So those would be the numbers that would not work.
Okay. All right, so with this example, we are subtracting, identify any x values for which the expression is undefined. So we would again want to find the least common denominator. Let's factor this x squared minus 9. That factors into x minus 3 times x plus 3. And we still have this 2x squared minus 30 up here. And then this one is just x plus 5 over x plus 3. So the least common denominator here is going to be an x minus 3 times x plus 3. And so if we want that in the denominator for both of these fractions, we're going to need to multiply this second fraction by x minus 3 over x minus 3. So we will have 2x squared minus 30 over the x minus 3x plus 3, and then minus x plus 5 times x minus 3 over x plus 3, x minus 3. Our denominators are now the same, so we can put these together as one fraction over this common denominator. And we may actually want to multiply this out using FOIL first, Ms. Bella.
Okay, so let's FOIL that out real quick before we combine these. X times x will give me x squared. Outside is minus 3x. Inside plus 5x. And last times last is minus 15. So that numerator really cleans up to x squared plus 2x minus 15. So if I want to combine the two numerators here, the first fraction had 2x squared minus 30. I'm going to subtract that from my second numerator. Again, I need parentheses here. X squared plus 2x minus 15. Now, if I want to simplify the numerator, I see this negative sign. I'm going to have to distribute it into each term in that second parenthesis. So really, my numerator right now has 2x squared minus 30 minus x squared, another minus there, minus 2x, and then we'll finish up with a positive 15. Again, all of this was over my denominator, my least common denominator here. So my final answer for this one will be combining like terms here. Again, I see I have an x squared term here and an x squared term here. So that will give me 1x squared. If I take a look at my x's, there was only one of them, so minus 2x, and then combining my constants, I'll have a minus 15. All of this will be over x minus 3, x plus 3. Again, making sure to mention what would make that undefined. I want to set x minus 3 equal to 0 and x plus 3 equal to 0. So in this first one, I'll get x cannot equal 3 or it would be undefined. In the second, I'll say x cannot equal negative 3 or my function would be undefined in this one as well.
Can that numerator be factored further in that answer?
In this one, actually, let's try to factor because sometimes some things happen and we can reduce just a little bit. I notice I have an x squared and I have a negative 2x minus 15. Product sum here, my product would be 1 times negative 15 or negative 15. My sum would be a negative 2. So that would factor using product sum to x minus 5, x plus 3. again, keeping the bottom as it is, this should look familiar to when we did that multiplication and division. And you notice x plus 3 on top and bottom can cancel out. So this actually simplified, going a little backwards here, to x minus 5 over x minus 3.
But even though we can divide out the x plus 3's, we still have to remember that our x's could not equal 3 or negative 3. That stands for the whole problem, even though we reduced. Okay, so some rational expressions are called complex fractions. A complex fraction, oh, that was not nice.
Sorry.
A complex fraction contains one or more fractions in its numerator, its denominator, or both. So here's some examples of complex fractions. Here, notice we have a fraction, in the denominator. Here we've got a fraction kind of added to an integer in the numerator of a fraction. And here we've just got a fraction divided by a fraction. These are all called complex fractions. Remember that the fraction bar represents division, so multiply by the reciprocal of fractions in the denominator. So let's take a look at this example.
Okay, so in our problem here, again, complex, a fraction within a fraction, kind of like the last example here. So I'm going to rewrite this as x plus 2 divided by x minus 1. All of that fraction divided by x minus 3 over x plus 5. So I have two fractions divided by each other. Following my rules of division here, I'm going to change this division sign into a multiplication, and when I do that, my second fraction will be rewritten as its reciprocal. So I'll flip the x and y there. So this first one can come down as it was.
So we don't flip the first fraction.
Nope, we only flip the second one. So change, and then you flip this one here. So same, multiply, flip. I think so, Mrs. Prince had some sort of saying like that.
All I know is dividing by a fraction, you multiply by the reciprocal.
Okay, so I'm going to multiply. If you remember back from our multiplication, I have these factors here, okay, multiplied by each other. So I'm going to multiply the top. So this will become x plus 2 times the quantity of x plus 5. And then on the bottom, I'll have x minus 1 times x minus 3. Now, there are no factors that are the same in the top and bottom, so I can't cancel anything. However, I could FOIL on the top and bottom. Should I FOIL on top and bottom for this one to clean up?
I would leave it.
Okay, well, let's leave it. But let's maybe mention what numbers wouldn't work still, where it would make it undefined. I'll say x minus 1 equals 0, or x cannot equal positive 1. X minus 3 equals 0, or x cannot equal positive 3. So there are two numbers there that I need to rule out.
We also need to rule out negative 5 because it makes the original denominator equal to 0.
So hopefully we see what she's saying there, that I missed this one when we were doing that. There was a denominator in that beginning that I didn't remember to put in here. So x plus 5 equals 0, so x can also not equal negative 5. So we really have three restrictions on that one.
Okay, so for this example, we are simplifying this complex fraction. And so with this one, we want to get a common denominator. Let's just work with the numerator. So we're only working kind of above this line right now. So we want to get a common denominator in the numerator. The least common denominator between x and 2 is going to be 2x. So if I want to figure this out, if I want a common denominator of 2x, I'm going to have to multiply this by 2 over 2. And multiply this one by x over x. So I'm going to get 3 times 2 is 6 over 2x plus x times x is x squared over 2x. And don't forget that's still over x minus 1 over x. Oh, Miss Bella, really?
Sorry, I like the highlighter.
All right, so moving this over here. Okay, and so now we can combine those numerators here that are the same. I'll risk the denominators are the same here. And so when I combine those, I'm going to get 6 plus x squared over 2x divided by x minus 1 over x. So we now have one fraction divided by one fraction.
Okay, so this is going to be very similar to how the I think I might just hit mute. Hopefully you guys can still hear us as I grab this. So as I go through this, we're going to write this as 6 plus x squared over 2x, that fraction, divided by the second fraction. Again, so our rules here will be to change this to a multiplication, and the second fraction will be rewritten as its reciprocal. So this first one will stay, the second one will flip. So I have each of these quantities multiplied by each other. So I'll multiply across the top, I'll multiply across the bottom. I'll end up with 6 plus x squared times x over 2x times x minus 1. Now, if I think about 2x, remember that's really 2 times x. So I have a factor of x on the top and bottom. If you think about this like 2 times x kind of separate a little bit, which means I can cancel an x from the numerator, and also this x can go away from the denominator. So I'll end up simplified with 6 plus x squared divided by 2 times x minus 1. Again, I want to rule out any numbers that would have made that undefined. So going back to our beginning, so we don't forget about that one. Again, we had x's in the bottom in the very beginning, so that means that x cannot equal 0. There's nothing to really solve in that one. Anywhere in my work, I ended up in a couple places with x minus 1, including the final at the end. So x cannot equal positive 1 as well. So I have two numbers in that case that I need to rule out.
Okay, here's your second notes must do. You are going to simplify 20 divided by x minus 1. That fraction is being divided by 6 over 3x minus 3. So that is your second notes must do.
Can we maybe give a little hint that in this one, you might want to do some factoring there? There's something in common you might want to take out that will help when you're reducing.
Yes.
And I think that finishes off our notes for
That's
today.
it. So make sure you've taken good notes and completed the notes must do, and we'll see you next time.
All right, thanks for watching.